Babu, the recording live, ma'am. Good morning to all gathered here. So a very warm welcome to our chief guest and all the participants who are joining this session today. So to start the session, just we want to give a few introduction about our college. A small video will be played just for 2 minutes. You can just see that, and then we can start our webinar session today. Link share. Link YouTube share. Link வந்துருச்சா? இல்ல பாஸ் பண்ணி நீங்க ஷேர் பண்ணாலும் அத பே பண்ணுங்க. குரூப் போட்டிங்களா? ஆன் பண்ணி விடுவா? ஆன் பண்ணு. Good morning to all. Once again, a warm welcome to this session. Good morning to all. Once again, a warm welcome to this national webinar. And we are celebrating this as a part of IEEE WIE, Women in Engineering Day, from 30th June to July 7. So daily we are having different sessions like a webinar, industrial visit, and our service to some community, to rural areas. So we are planning so many events, and we are making use of this facility. And we are extending all our services to the students community and to the faculty. So today we have gathered here for a national webinar from ISRO senior scientist, Mrs. Nisha. So before proceeding with that webinar, this webinar is organized in association with our Center for Space in our college, Rajalakshmi Institute of Technology. Now I request the center head, Dr. Chandra, the head of Center for Space of RIT, to give a few words about the center and activities that are going on in Center for Science. Over to Chandra, ma'am.
Thank you, Professor Lalita. for organizing this grand event. And it is a proud moment to RIT, Rajalakshmi Institute of Technology, having our eminent guest from ISRO, Ms. Nisha GR, Senior Scientist, Vikram Sarabhai Space Center. We welcome you, madam. On behalf of Center for Space, I'm here to present the various activities carried over for our students in our center, Rajalakshmi Institute of Technology. Now, madam, for the past 4 years, this center has been established during the year of 2021 and 22, and we have invited eminent scientists from ISRO and DRDO. In the year of 2022, we conducted 2 days DRDO sponsored guest lecture, and guest are Dr. S. Krishna Kumar, Senior Technical Officer, CVRD, DRDO, and another guest from CVRD, DRDO was Dr. S. Nagesh, Scientist F, Project Director, Aircraft Project Division. And also we had our guest from Vikram Sarabhai, ISRO, Dr. L. Srinivasan sir. He also delivered a lecture on space exploration and future scope in satellite communications. And we had a guest from former scientist from ISRO, Professor R.R. Ilangovan sir, and sir has delivered a lecture on advancing researchers in frontiers, AI in space communication and aerospace. And also we invited guest from IIT Madras Project Associate, Mr. Ashwin Kumar. And the outcome of all these events, our students were able to do a project in various concepts like design and development of payloads for student version. Our students have developed their own payload. We have the history of Rajalakshmi Institute of Technology. On behalf of Center for Space, we launched our payload, one of the payloads in Vikram S. Skyroot launch. So this is one of our moment created from Center for Space by our students. And we our students have done design and development of ground station, satellite ground station. The concept of this project is we have our own satellite ground station to track the low Earth orbit satellite. This is developed by our UG students, in which the students from multidisciplinary department have involved, like EC department, CC department, CS BS department students, and VLSA department students. All these department students have contributed to design this project. And next we are planning to do model rocket also. So these are all possible with the help of our previous guests, those who visited our institution. And for this, we are thanking our management, Rajalakshmi Institute of Technology, for providing great support in implementing all these projects. So, and again, we are our students and faculty team have registered in the India Space Academy, where we are doing their our summer course for a course period of 1 month. Under this summer course, our students and faculty, we are able to do various projects which are allotted by the summer school divisions only. So we have completed 2 projects under this, estimating the dynamical mass of a galaxy cluster, and another project is ongoing, predicting Hubble parameter and the age of universe using supernova 1 year data. So these kind of supports we are getting through the summer school activities in alignment with ISRO. So we are thankful for that, and we need the support from great eminent personalities and scientists like members like you. And it is the moment we are taking to thank all the scientists, those who supported us, and our management also. Thank you, madam. Thanks for Dr. Lalita, and to organize this event in association with the Center for Space. Thank you.
Once again, speaker. Speaker, once again. Okay. I think it's audible. Thank you, Dr. Chandra, for the brief introduction about the Center for Space in our college, RIT. Now I take this moment to introduce our chief guest today, Mrs. G.R. Nisha. So Mrs. G.R. Nisha completed her BE Electronics and Communication Engineering from Institute of Road Transport Technology of Bardiyar University in 1996. At this moment, proudly I say she is my alumni. In the same college, I also studied along with her. So she's a proud alumni of my UG. She joined in Vikram Sarabhai Space Center of ISRO in 1997. She completed her MBA from IGNOU, New Delhi, and pursuing her PhD in Electronics Components Management at IIST, Trivandrum. She is expertise in designing of digital avionic subsystems like onboard flight computers, sequencing electronics and command execution modules for various launch vehicles like PSLV, GSLV, GGLV M3, RLV, and HSP. Also, she is expertise in verification and validation of VLSI design logics and ASIC designs of various digital subsystems and evaluation of various electronic components like FPGAs, microprocessors, microcontrollers, high-speed memory devices, and mixed signal devices as part of component reliability program of ISRO's launch vehicles. She published many papers in various national and international conferences, seminars, and international national journals. So she has actively participated in many IEEE conferences in 2011, 12, almost in every year. And she has also presented a paper in International Seminar Aero 2013 at DRDO, Bangalore. And she is also an active member in System Society of India, SSI, Indian Society for System Engineering, ISSE, Society of Aerospace Quality and Reliability, SAQR. So we have such an eminent personality here with us today to celebrate this Women in Engineering Day. Over to you, ma'am. Very proud of calling you, and you are kindly accepted an invitation to present this webinar. Over to you, ma'am.
Yeah, thank you, Lalita madam. Actually, okay. So good morning, all. I am not seeing any students, only participants, 4 only. Students are there on the other side, isn't it?
Yes, ma'am. Ma'am, YouTube live link has been shared to all the students and outsiders.
Okay,
In
okay,
Zoom
okay.
link only we will be here. That
I,
link has been shared.
Okay, okay. I think mostly ladies are there. Women.
Mostly ladies and other students, faculty from other colleges also.
Okay, fine, fine.
They
So
are
good
there.
morning, all. I am Nisha from ISRO. That one of the leading center of ISRO. It's a largest center of ISRO. That is VSSC. That is Vikram Sarabhai Space Center. And so here only we are design and development of rockets. Normally we will tell it's launch vehicles, LVs. So the design, development, all the core technologies we are only making. So as part of Indian space systems, both the rockets and satellites will be there. So we are the development people of research and development people of launch vehicles. So this is my introduction. Here I am completing my 28 years since from 2097 I joined and now become as a senior scientist. My basic domain is electronics and I'm working in VLSI domain. So this is the small introduction about myself. So I will share my today's presentation. So is it visible, madam? Hello?
Yes, ma'am, visible, ma'am.
Okay, I'll start. So my topic is I'm going to present the women's contribution in Indian rocket technology. So this is my agenda actually. So first I will give a brief introduction, then which are all Indian space systems, how it is organized. Then in Vikram Sarabhai Space Center, that is the leading rocket R&D center. Then what is the significance of STEM education for women? Then women engineers and scientists, how they evolve. Then what is the significant role in rocket science? I'll briefly explain. Then the achievements by them. Then finally a short conclusion. That's all. So this is the introduction. So space systems means it's rockets as well as satellites. So the main aim is to send the satellites in a particular orbit. So for that we need some vehicle. So that is called launch vehicle. So in commercial term we are telling us rockets. Terminology-wise, it is launch vehicles. So different types of launch vehicles we are making. Initially, we have done some small launch vehicles. That is led by Abdul Kalam. That's the first SLV, satellite launch vehicle. That is here, Vikram Sarabhai Space Center only it is started actually. Because why it is means, the significant is here only that equator is passing near Trivandrum. So the gravitational pull will be less when we are launching the rockets. So that's why it is called TERLS. TERLS means Tumba Equatorial Rocket Launching Station. In 1974 kind of thing, it is started by Vikram Sarabhai. Then after that only, satellite and all that time we are not done because we are brought out from US and USSR and all important and with this launch vehicles. So we just demonstrated in a small vehicle. Then SLV has developed at that time that the severity of launch vehicle is more actually. Suppose it is a solid propellant and liquid propellant, something has happened. It is a small city in and around Trivandrum. So the land masses will be very get damaged if something has happened because that time we are doing some research and development. So that's why we shifted to Sriharikota. That is named as Shar. Now it is in Andhra Pradesh, near to Chennai. So any launch port, if you are seeing, it will be near to the sea because the landmass they will not cover because it is very critical and a dangerous vehicle actually. Something has happened in a wrong way, it will damage the entire city or the town. So that's why any spaceport, if you are taking, it will be near to the equator as well as in a sea, near to the seaport. Then women's contribution is significant from design stage to launch stage in our center actually. That I'll explain. Then women in administrative and auxiliary service also there. They are supporting us actually. Whoever is in the STEM area, they are supporting. So in both way, technical and non-technical way, women are here. So they are immensely contributing. So we cannot avoid that women power in our center. It's the largest center in ISRO. Then we are doing the major achievements are we are part of all the missions from mid 70s, 80s onwards. That is launch vehicles, the commercial launch vehicles are PSLV, GSLV, Mark III. There is a heavy duty launcher. Then as well as Chandrayaan, Aditya L1. These are the payloads actually. Chandrayaan 1, satellites only. Payloads, Chandrayaan 1, 2, 3 and Aditya and all. But the vehicle had to send for them, to send to the orbit at the particular place. So that are designed by us actually. So our role is very important in that. Then the safe working environment infrastructure with the latest technologies are, so here in our center, it is very empowered working environment. So we don't want to worry about anything. Everything is possible here to work in a positive way. So that's a real thing. It is boosting us. So these are the things I am going to cover in this session. So first, Vikram Sarabhai Center. It's a birthplace. I told towards Tumba Equatorial Rocket Launching Station. Nowadays, we are sending only small rockets here, atmospheric studies, that is sounding rockets. So if you want to visit if you want to witness that launch every month, 3rd Wednesday, around 10 to 11 o'clock, if you are coming, you can witness the launch. So other high launch vehicles, that is PSLV, GSLV, that and all we are doing in a Shar, actually, Sriharikota in Andhra. So PSLV means polar satellite launch vehicle. So like our weather satellite, IRNSS kind of thing, weather, water and other things and all, we are putting in the polar orbit. It will be around 200 to 400 to 800 kilometers from the Earth. So it will be crossing India 11 times. So 11 samples we will get. That's why the weather and all we can predict in a correct way. GSLV means geosynchronous orbit. There's an orbit of the communication satellites. Our GPS, WhatsApp, cable, that channels and all, TV channels and all working on that inside kind of satellites. That's the rotation of the orbit and the Earth rotation or same, one-on-one same. So it looks like stationary. If you are putting the satellite there, it will looks like stationary. So we will get the real-time data. So that's why that's high, long duration it has to go. It is around 36,000 kilometers from the Earth. So that's why the heavy duty launcher. vehicles like GSLV Mark III are designed, and we are sending the communication satellites. I think it's clear. One is weather and that kind of satellites. Another thing is INSAT satellites, communication satellites. So the two type of vehicles. Another thing is Mark III. It's a 4-ton vehicle. The payload will be 4-ton. For that also, the engine configuration is different actually. Stages and all very less, but a heavy duty it can. GSLV only can take up to 2 ton. This is 4-ton. This only that Gaganyaan crew, the human is going the next year actually. Now one Shukla has gone, Subhanshu. That is gone by other vehicles. Our vehicle is not yet ready. So that type of vehicle is configured with the GSLV Mark III. So Mark III commercial vehicles are going, but it is a customized vehicle is going with this Mark III vehicle with the crew module adapter. It's in the next year. So our major work here in Vikram Sarabhai Center is the second line, design and development of Indian rocket systems and technologies. So here, what all of the stream is coming means physics, chemistry, that is comes under the science, and engineering stream, electronics, mechanical, computer science, structure, civil, metallurgy, mechanical, everything will be coming. So this is the core area, domain only. It is coming here, not the specific like AI, IT, then what it is, power electronics, not kind of thing. Core technology only here. Then more than 30,000 professionals are working here. Then out of that, 30% are women. Then it is a 50 years old organization. So we are developing various types of launch vehicles. SSLV is the small satellite launch vehicle that will be sending the rockets in the lower Earth orbit, which is around 100 to 200 kilometer from the Earth. So it will be definitely replacing the existing mobile towers in the future. So within 5 years, mobile towers will not be there. The routers kind of satellite will be covering the Earth in the LEO orbit. It's a lower Earth orbit, just after 120 to 200 kilometers from the Earth, it will be revolving. So this is the space market is highly for this SSLV. So STEM education. STEM, everyone knows it's a science, technology, engineering, and mathematics. So it's a core thing. So here in our thing, the prominent engineering streams are electronics, computer science, electrical, civil, structural, and mechanical, or the really contributing in the rocket engineering streams. The physics and chemistry are the major two important science streams in rocket science, because that physics is astrophysics, and on space physics laboratories there, they are making a lot of projects and studies. Real R&D is making here in physics department, chemistry department. Chemistry is what it is doing is all the coatings, some specific paintings, that's all required actually. So then propellants, solid as well as chemical, liquid propellants, and that and all, everything is actually indigenized from here only. So it is starting in the 1970, and within 15 years, everything is started from the scratch and we indigenously developed. That's the proud thing actually. So many, in physics and chemistry, so many ladies were there, women were there. They are all pioneers also now. Then electronics also, then if you are taking, electronics is the most demand area for women actually. Then computer science demanded only proportionally less, because you all know electronics is the mother of computer science and electrical also. So electronics people can do computer science also. The civil and structural are very less. Mechanical is almost, it is also very less. Like the ratio we can see in our college, that's the thing we can. So that's why the fourth point, 50% women are in electronics, 20 are in computer science, 20 in physics and chemistry, and 10% in structural, mechanical, and electrical. Overall, gents, if you are talking, that's the different ratio, but I am talking about only women. So this is the ratio. So electronics is the highly demand. So I'll explain why. Because the vehicle is totally unmanned. It is not a manned, or a pilot is not there. So the unmanned vehicle is controlled by the electronics, that systems, that is called avionics. So the avionics is designed mostly by, mostly means, okay, some male engineers are there, but mostly our electronics, our avionics blocks is covered with mostly with the ladies. That's why the 50% of the total women power is contributing in electronics. That's an avionics side. Then associated some quality related works also. Then these are all the avionics. That's the main function we are working actually. Navigation, guidance, and control. I told that's unmanned vehicle. It is controlled by the indigenous avionics systems. That one is the inertial measurement unit. That is the sensors and accelerometer, gyros and accelerometer will be there. It will acquire the data and feed it to the flight computer. So processed and flight computer will decide whether the data is correct or not. Then it will process, the high performance processor will be there. Then based on that data, it will analyze and it will steer the vehicle with its own guidance and control algorithms will be there inside there. So that's the thing. So that's the navigation algorithm will be embedded in the flight computer. The computer will manage where to go, how to go the vehicle. So it will steer and maneuver the vehicle accordingly based on the inputs received from the IMU and with the help of navigation algorithms, it steers the vehicle in a particular launch profile of the vehicle. Then actuation system. Actuation system means that the vehicle has to should have the control. The control commands are given by the flight computer, but the vehicle has to control, so the actuator systems are there. Electro-hydraulic and mechanical actuator systems are there. So based on the command received from the flight computer, it will control, that is pitch, yaw, and roll. These are the three controls were there. So within that, with that, it will control and go actually. So in that way only the vehicle is going. So in this area only we are all working more actually, more ladies are there. Then the same, this kind of development, both electronic systems, the software coding, actual hardcore software coding, not like high-level languages and all not there. Flight computer division means if you are taking that microprocessor coding, circuit design, that system, subsystems design, everything, number of that we called as a packages kind of thing. So that is number of packages we are the most people we are designing. So for that, we have to assure that whether the particular requirement is captured correctly or not. That is set of parallelly one quality assurance people will be there. So this is called quality and reliability. So here we will check actually whether the desired function is implemented correctly or not. Also, we will put those subsystem in the environment because the rocket is going to an extreme temperature also. So our operating temperature range is -55 to +150 degree. So in that thing, all the tests we will do, vibration, shock, acoustics, all the things. Then as well as the functional thing also. So for that also, the ladies are involved actually. Then all the design reviews from small components to high level that systems also we are involving to review and checking whether it is correct or not. Then quality control, the test automations, not the manual testing, nowhere it is applied. All are test automations, then verification, validation of all the codes, software, everything. Then checklist-based verification in the integrated launch vehicle. Then SOP, standard operating procedures, because everything we are not on the spot, we are not deciding like that. Everything standard procedure complies to some standards, IEEE or ISO, like the kind of things and all we are following. With that only, the reviewed SOPs will be there. So in that also, people are there. The reliability analysis, here is a mistake actually, it is a prediction analysis. Suppose we are having some past data, from that we will predict the failures or how it will be, both kind of things. In that also we are working. The failure analysis, suppose failure will be happening. So here, it is a very critical mission. Launch vehicles are categorized as critical missions because one small failure is enough to destruct the entire launch vehicle rocket actually. So we are very concerned about a single failure, single resistor or capacitor or microprocessor, one leg or one timing issues. That and all we are very cleanly, we are giving the attention. Otherwise, no, we cannot tolerate the failure. That kind of failure, we will call it as a catastrophic failure. It is a very dangerous failure for the entire, for one launch vehicle, it is the cost is around 800 to 1,000 crores actually. So that we cannot tolerate. Then if you are sending the crew, then it will be, the safety also will be there. Then it is priceless actually. Without human, somewhat we can tolerate, but other things we cannot. So that's why the concerns for failure we are putting is very, 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 very high. Then that methodology is FMEA and FTA and all. Then quality management reviews also will be there. So in this also the parallelly women power is involved. Then aerodynamics and structural. The rocket aerodynamics focus on minimizing the drag and ensure stability of the thing. So for that, the ground before designing during the design phase of the rocket, we are doing that FEA based. There is a finite element analysis based, structural engineering based concept. And there also a lot of women are there. Structural engineers are there. Then women roles in rocket science. That's the positions I am telling, roles. Engineers, obviously, that's a major part actually. They are going to design of systems, test automations, software coding, data analyst, VNV, that's a verification validation, quality assurance engineers, and robotic also nowadays there. Robotics design engineers. Basically, that is the core thing is electronics only. So electronics people can do anything, coding, electrical, then automation, test, everything we can do. And then in here, every design of system means every engineers are there, every stream, if it is software or mechanical or structure or civil, everything is there. So civil is not directly involved with the rockets. They are associated with the infrastructure development, the buildings and others, launch pad constructions, that and all the civil engineers. Their ratio is very less, but it is unavoidable. Then technologists, they are actually involved in the R&D, innovations kind of thing. BTech and MTech graduates, MTech specialists will be directly recruited in this category. So engineers also evolving over the years and they are become as technologists. Then scientists, that's a space physics, chemistry products for rockets, and that's they are becoming scientists. Actually, our designation is scientist only. Then we are starting when we joined in at that time, we are treated as engineers only. Over the years, we are becoming technologists, then we are becoming scientists. We will have some lot of patents, R&D, publications, everything will be there. Then automatically will become a scientist. Then techno managers. BTech is more than enough. B and BTech is more than enough to join in ISRO. Then techno managers. Over the years, after 15, 20 years, we all will be removed from the lab and will be putting for the managerial post. That is called a techno managerial because it is purely 100% a technical organization. So that's why it is techno managers, the senior engineers, senior scientists and engineers. Then technical assistants. There also ladies are there. They are purely assisting engineers and scientists. Then technicians. Technical assistants means they are diploma holders. Then over the years, they are also becoming as engineers and they will coming as engineers grade only. Then technicians. The technicians, they are helping the engineers and the technical assistants. They are hardcore people. They are CAD/CAM design, PCB design, fabrication, wiring, ITA holders actually. They are ITA, Polytechnic, that kind of degree they are having. They're giving the QC checks, the lab assistance, calibration, maintenance, testing assistance. Actually, engineers will develop all the developments and other things. These people will help actually. The remaining that hardcore things have to be fabricated and realization, in that phase they will. All the things cannot be done by the engineers. So these are the assistants. Here also a lot of women are there. The precise works are coming from the technical assistants and technicians only. The fine tuning, because the PCB wiring and PCB fabrication and all example, it is a very fine tuning work, a precise work. And sometimes the testing works, and all very fine and things that are required that women can achieve actually, rather than gents actually. Then women roles, the continuation. Then other than technical, we are having other non-technical people also, because they are mainly supporting the technical stream as administrative officers, because we are having some general and personal activities related things like our salary, health, then our a lot of general administration kind of thing, that and all they are holding actually. Then purchase and stores officer, they are supporting the infrastructural activities. Suppose if you want to develop some infrastructure or some facility or lab, we need not intend actually. They will collect from the requirement from us and they will support, and they will interact with the vendors and manufacturers, and they will get it for us, because concurrence with our specifications and requirements. So that's a separate department. So our mainstream activity will not be affected. They will be supporting us in that structure. Then definitely accounts officer supporting the budget activities and all. So I think if it is in other organizations and corporates, everyone will be concerned with the return of investment and other things. Here, as engineers and scientists, we need not bother up to the ROI. That is, in our level, it will not be influenced actually. Actually, it is done by the accounts officers and a higher grade people. They will be budgeted. Whatever budget if you want in a reasonable way, they will give actually. So like a freedom we are having, anything we can buy and we can put, we can develop, we can do some innovation. So that kind of freedom we are having. Then truck drivers also, women are there, especially not the commercial truck. Actually, that two launch pads are there in Sriharikota. One is fixed, the vehicle will be moving. Another one is vehicle will be integrated and fixed, tower will be moving. At that time, the vehicle is moving is with one truck only it will be. That's a very heavy loaded truck. It is designed like that. On top of that only the vehicle will be first stage, second stage will be integrated for over the 1 month. And finally it has to move from to the launch pad. The truck is driven by some ladies actually, women, they are there. Then obviously canteen staff, then cleaning staff, everywhere there. So all are recruited with in our office, that gate you have to cross, in any stream, we want to enter and cross the our campus gate means you have to be one or the other way, you are the topper in your class actually. In that only the recruitments will be there, even with canteen staff or peon or one cleaning staff, the driver, and doctors also there supporting our health actually. Everyone is the toppers. So the plus is also there, minus is also there, but it's a healthy atmosphere. Very, intelligent, the brilliant atmosphere will be there. Everywhere when we are talking, the brilliance will be flourished actually. So that's why the atmosphere will be very good and empowered actually. Then achievements, significant roles in all missions from mid-70s onwards. Mid-70s onwards, fully that women are recruited. Started the women recruitment. Nowadays, it is increasing like anything. But total power, we are only 30% only, comparing to the total manpower collectively in our center. But okay, we are significant role we are having. Then reliable missions are possible with the precise working culture. So one story I can tell, because when the earth is created by Brahma, it was totally black and white. It was not colorful. Then he was worried because nothing is happening, only black and white. It's not look good kind of thing. Then only the other people suggested that you create, make it colorful kind of thing. So how to create? At that time, the Saraswati created. So she made the earth into colorful. So in the same concept only here, reliable missions, the precise works and all, the main brainy works and all we are only doing. That's the algorithms, the guidance, navigation, electronics, automation, systems and all we are doing. That's this line. Then out of this 30%, 10% are in top positions and leading their team. The others are juniors fully. Then the 10% are doctorate and pioneers in their work domain. They are having n number of research publications and patents. Then we are all very adapted to dynamic work environment. Suppose morning we will come to work. At that time only they will tell. Hello.
Hello, ma'am.
Share. Interrupt. Share. Screen is not there, no?
Yes, yes.
Okay. Once again, I'll share. Now you can see.
Yes, ma'am.
Yeah. This is the thing. So adapted to dynamic work environment. What I'm telling is now today I'll be coming to office. At that time, a sudden requirement will be go to some tester, some participate in the meeting in the Bangalore headquarters or in the Sriharikota. Immediately we will go because that much flexibility and facility our center is providing, and these are all done by the women. Previous seniors, they had done very good workplace actually. The government is also supporting all the cells and other things. So we need not to worry about anything. That's why I put a last thing. Without any barrier, the safe environment and empowered workplaces constructed here. It is formed here actually. Without any barriers, I can travel, the accommodation everywhere. If you are going, it is a very safe accommodation. Our guest center will be there. Any meeting anywhere in India, I can go and even alone we can go and participate. Stay back duty, even night 10, 11, up to 2 o'clock and all I worked here without any problem. The launch campaign activities, sometimes 1 month, 10 days to 1 month that we had to be there in the sharp. There will not be any problem actually. That much facilities the government as well as the center is providing. These are all, this is once again, it is achieved by the previous women scientists and manpower only. Then our health is also protected by our center. So we cannot worry about anything. We can work actually. It's a good dynamic work environment. Then latest technologies we can buy, we can work. And that's a freedom actually. First of all, I tell that the freedom is there. That's why we could be able to contribute more actually. So that's the conclusion. Okay, women are not just participants, but indispensable drivers of India's ambitious space missions. Their contributions span every facet of space program, from design engineering, design to launch actually. Women are not just participants. Okay, same thing I have. Okay, sorry, that first line, first paragraph, that's a duplicate. So I am telling that it is without women power, that it is unavoidable nowadays. In mid-70s and mid-80s and all, the ratio was very, very less. That people, that engineers and scientists, they got retired now. They were not there. Now we are in the thing. But we are seeing nowadays a lot of women people, young girls and all, dynamic young girls and all coming actually. They are not from IITs, IISTs, even prominent colleges. They are coming. It is screened by some return test and gate level, gate model kind of exams followed by interview that they are recruiting. So I told, everyone is in one or the other way in the toppers in the schools and colleges. So the brilliant atmosphere is steering the vehicle in a good way. So that's why I put it's a precise and like a woman can nurture anything, once she got it in her hand, she'll be care like anything, like a mother. We are mothers. Once we got a child, child, the safest place is his mother's hand only. So like that only, for that only I represent this figure. So in our hands, that reliable missions. Reliable missions means without any failure. The missions are very successful. Missions are possible along with the GENS community, and we are also putting the precise to work for the successful and reliable mission. So I am welcoming each one of you to join ISRO. So it is a very safe and dynamic workplace. So welcome you all. Thank you. So any questions, I will answer. That's all, ma'am.
Yeah. Thank you, ma'am. Very informative session. If you have any questions,
Ma'am, I have a question, ma'am.
Yeah.
Ma'am, as a student version, what kind of innovative projects that we can establish, especially for patents? Can you give some inputs in this regard, madam?
Yeah, actually one cell is there in our center. That is the Respond program. Have you heard about Respond?
I'm not audible, ma'am.
Now it is audible?
Yes, ma'am.
One Respond program is there. That every 6 months they will call. Actually, I'll give the focal point number. Then in that thing, if for any launch vehicle, any electronics or any domain, you can put some proposal. Then they will allot the fund and other things. One internal guide also will be there allotting. Then every 6 months they will review it. I think maximum 3 years or something. Within that, you have to complete your projects. I think PG graduates and all, they can get mostly things. Then innovation, anything can be happened. Then this every year their internship is also calling. So second year onwards, they can participate in the summer internship project and summer internship. At that time also, if anything is there, online you have to apply and come and doing it. You have to get the approval. So now it is all India level, all over India, they are screening and doing. So if your people are coming and developing something, they can put some innovation. Here they will not support. I think from here you can develop and your college can.
Not audible, ma'am.
Not audible. Now it is.
Now it's audible.
Actually, Respond program is good. That PG students can cover.
Okay.
Other things, BTech, BE people, the second year onwards, that internship program is there, summer internship.
Yes, yes.
So there also they can, 1 month they can work here and do
Yes.
it. Then I think patent external people, our office will not support. Your people can do it. In a college can file the patent and other things. But you can come and work and do it. That's the thing.
Okay, thank you, ma'am. And in the YouTube live in the chat box, some questions are there. I'll read out the question, ma'am. Others, if you have any question, you please type in the chat box in the YouTube. I will ask the question to ma'am. So Divya Muralidharan has asked two questions. First question, what quality or personality you expect from a woman to have their work-life balance planning to work in ISRO? Second question, how would you keep yourself updated to the new technology despite the busy schedule? That's my question also.
Actually, quality and other things, just you read your subject very thoroughly. Thoroughly means understand the principles and the basics, fundamentals. First, if you're a simple example, I'll tell you. If you're coming for the interview in ISRO, they'll sometimes they'll ask what is Ohm's law. If you're telling, okay, V equal to IR, if you're describing in a way, you will not get it. So, but there is a definition. At one fellow was telling that, constant current going through the things, it depends upon the resistance of the thing and all. But there it is a very important perspective at constant temperature. Then only V equal to IR is relevant. A constant temperature is not there, it will not be. So if you are not mentioning in your answer that constant temperature, you'll be out. If you are telling at a constant temperature, you'll be in. So that's the specific way of, so if you are understanding the concepts and principles very strongly, then you are eligible. So study your subjects very thoroughly, actually. Thoroughly means by knowing the inner things, the core, you have to understand it. Then it will be very easy. Basically, the funda should be very clear. Then you can, any building you can construct over that. So just be is enough, actually. Then sometimes only specific requirements is there only they will call the MTech actually, PhD and MTech people. So we only nowadays they are calling, so many people have got retired. So I called, I think June 30th, last date or something. Exams followed by this thing. So GATE exam model only, ICRB exams. So that you have to prepare. So GATE exams once again, the core engineering principles only. So that's the quality record for entering into ISRO. So second question, how I am updating, isn't it?
Yeah,
So
yes, ma'am.
yeah, that is basically on interest. And I used to read the journals actually, journals and magazines. My favorite magazines are EFI, Electronics for You, the Data Quest, Spectrum kind of things. Then now I am pursuing my PhD also. So, okay, reading a lot of papers. Then twice in a year, I mandatorily publish papers, 2 papers, attending conferences related to that. So advanced things, subscribing that digital magazines in my through my mail. So then and there, I'll scroll it and do it. So participating in the conferences, workshops. Then and earlier and all I used to attend. Nowadays I'm sending my juniors. Okay, it is nowadays the resources are very large, In your hand, it will be available. In our days and all, we had to go to library.
Exactly.
Madam, in our
Yes, yes,
library, I a
yes,
lot of
yes.
that EFI magazine I got
That's what
it
I
from there
remembered
only.
immediately,
In
like
my
EFI.
table, it is there
Yes,
actually.
yes.
So it is a way. There is a one caption is there in EFI. I started reading this magazine as a student. Still, I am a student to read this kind of thing. So that is a very updated magazine, actually, very reliable also. So in that way only. So after some time, the subject is very less. After some 10 years and 15 years, you will cover all the concepts of the subjects and implementation, everything. Then after that only, you're looking for the new things only. So new things you will get it from attending conference, journals, papers only.
Correct.
So try to put your projects or small mini projects, main projects, and based on some research paper. Then it will give some insight into you. Okay,
Correct.
that is okay.
And the same participant, Divya Muralidharan, has asked another 2 questions.
Hmm.
Kindly share your journey of getting into ISRO. And next question, what are the qualifying exams of ISRO that are available for engineering students?
The second question I told you.
Yes, Amma. GATE. Everything.
GATE model. If you after completing your graduation, go and join any GATE forum coaching centers. 6 months, if you are taking the training, you will know how to do it, how to attack the questions and all. Then my journey is after 96, I finished my college. Then 97, I joined. In between, okay, I am a passionate hardcore electronics person. During college days itself, I will do some lot of projects and other things because when I joined, that is at that time, lot of IT boom was there. My classmates and even mechanical auto people and all joined in IT industries, but I didn't join. I'm firm on that. Then okay, that interest maybe to join here actually. At that time, there was no entrance exams actually, only interview. They will shortlist the candidates with the marks only, screening. So I got some marks in the college. Then maybe I studied by understanding the principles maybe in a strong way. So they asked some questions. Over 1 hour, 40 minutes interview was there. I got selected. Okay, after that also here software only they put actually. Then I denied actually. I want electronics, I told firmly. Then after 1 month only they allotted the division. So now I am becoming because I am a passionate hardcore electronics person. So drive your passion. Then you will find the way and you will be thrown to that place actually. That is my thing. Okay.
Okay. And for my question, ma'am, what type of any programming languages you are using there? Is it C or anything else?
Madam, I am a hardware person. So HDL languages, hardware description languages,
Okay.
C also people are using plenty. C is a standard language only.
Correct.
Now it is coming. All the things are in the sets of that. The Java
Correct.
also in test automation and other things and all. No, people are using checkout. That is a test automation. The PC based checkout automation. There are also real time C, Java in some. Then Linux also people are using Linux programming.
Okay.
The operating system. Then in our ADA also the people, that is our guidance and other things and high level language, that is ADA language, ADA high level language they are using. That's under very structured actually. Safety point of view, we can use this kind of languages. The military standard components only we are using, military standard languages. Everything will be compliant with the standards only will be following. Some all languages we will not use. That will not compliance to some standards. Then hardware languages we are using VHDL, Verilog, System Verilog kind of thing. That's all once again IEEE standard compliance to. So in that way only we will use here. Otherwise, because I told rocket is a very critical system. That's it.
Thank you, ma'am. That's all with the questions, I think.
I think very good. Thank you.
No more questions are there in the chat box. Okay, on behalf of our management, our faculty, our principal, Dr. Maheshwari, who has given this approval to organize this webinar. So I thank our management and principal, vice principal, and center head who has collaborated with me, Dr. Chandra, for organizing this session. So it's a really very useful and very motivating and inspiring session, ma'am. Definitely I can say that it would have inspired the young minds, especially girls of our college. So to join ISRO, we should also contribute something to our nation through this particular technology. Definitely it would have inspired young minds, I believe. So as you said, they should follow their passion and they should work hard and come up to that level. And once again, and you readily accepted my invitation when I asked you last week to present this particular webinar out of your busy schedule, I know. So thanks a lot, ma'am, and thanks to ISRO also for permitting you to present this webinar, national webinar. And because of you, many people from outside colleges, not only our college students, it's a national.
Very nice.
Yeah. So we had a WhatsApp group. We created the Google form link, and those who have registered, they joined that WhatsApp group, and this YouTube live link was shared there. So through that, many are watching. So it would be many would have benefited by your webinar. It would have inspired the young minds of many people. So once again, on behalf of all participants, all students, and our IEEE student branch chapter. So it's a very notable, event in our WIE, Women in Engineering Day celebration. Definitely, I can say. So once you should come to our college also, ma'am. Once time permits, I'm in a physical mode also.
Yeah, because I readily accepted your thing is because it's online.
Exactly.
Now also I'm sitting in office only. Okay.
Yeah. I know.
Okay, that's offline. We'll see, madam.
Definitely.
Okay, definitely. Okay.
Definitely. In advance, I'll tell you once you can come here and motivate our faculty and students. So,
very good.
1 second, our center head wants to talk. Chandra.
Yeah.
1 second.
Madam, thank you very much.
Yeah, thank you, madam.
As you mentioned, nearly 30% of female expertise are there in ISRO and VSSC, and I hope that our next generation community female candidates will follow and will be inspired, as Lalita madam mentioned, and our student community will come up with passion, and they will also follow as you, madam. Thank you on behalf of Center for Space.
Thank you, madam. Thank you very much.
Okay. Thanks a lot, ma'am. Thanks for all participants. Thank you, ma'am. Thank you.
Okay, shall I leave, ma'am?
Yes, ma'am. Thank you, ma'am.
Okay. Thank you.